have to study for the MCAT, so you're going to suffer with me. Let's talk about Bronsted-Lowry theory. Or, if scientists weren't so self-important, the much more intuitively titled proton theory of acids and bases. So Bronsted-Lowry theory says that when an acid reacts with a base, it forms a conjugate base and a conjugate acid. Now, the symbolic equation has always confused me. Don't ask me why, so instead let's look at a slightly more biologically relevant example, the dissolution of acetic acid in water. So, as the name might imply, acetic acid is going to be our Bronsted-Lowry acid, which makes water our Bronsted-Lowry base. And we can identify these as such because when we draw in our arrows of what's happening, and I've kind of given it away by filling in the right-hand side of the equation, our Bronsted-Lowry base, water, is going to be our proton acceptor, which means that it takes a proton from our proton donor, or our Bronsted-Lowry acid, to give us our conjugate base and our conjugate acid. Now, if you're having a hard time identifying the conjugate base and the conjugate acid, I recommend just looking at the right side of the equation and asking yourself what would happen if this equation went in the reverse. And as we know, our base is going to be our proton acceptor, so in this case our acetate ion, and our conjugate acid is going to be our proton donor, or in this case, our hydronium ion. Looking at this equation on the whole, we have two conjugate acid-base pairs, the first being our acetic acid and our acetate ion, and the second being our water and our hydronium ion.